This is the third part of the beginner series for creating your first or actual second game. So let's just jump straight into it. So let's proceed and start working on level 3 and we'll get back to this later. So for level 3 I was thinking as a puzzle element we would just do a simple platforming part. So we'll create some platforms that move around, some platforms that blink in and out of existence and allow the player to navigate through some rudimentary little obstacle course, and if the player manages to get to the end of the course there is something over there which allows to take possession of the very last character, or maybe we'll just have a end teleporter at the end of the course, and whenever that part of the course is reached the game is over and we're presented with some kind of victory screen showing us our time it took for us to get the whole way through or something like that. So let's get started and do that. What we're gonna need is, first of all, we're gonna create a folder for under a blueprints folder for level 3 for something that's specific for level 3. We should possibly clean these up as well, but I don't think we created something that was level 1 specific. Anyway, you're free to reorganize this as you see fit, of course, to have a structure that you feel you're comfortable with. But what we're going to be using is we create a blueprint class of actor. Call it BP underscore. Let's call it facing platform. So this will be our platform that we can jump on and that will, during some intervals, phase and out, in and out of existence. So we'll start with our visual representation, since that allows us to be it allows it to be more clear to have it in the world. So we'll call this our platform mesh, and we'll use the cube because the cube is awesome, like so. And from here we want to have some basic logic. We want to have some sort of trigger to say that this this platform should no longer be possible to stand on. It has phased out of existence, so we'll create an event for that. So a custom event, we call it phase out platform, and we want to have an event that also allows us to return to this state, so we'll create another custom event and we'll call it phase in platform. And the only thing we need to do when these events are called is basically to say this platform and set collision enabled, which allows us to change the collision that this platform has. So from the start it will have block all dynamic, so it will stop anything from passing through. When we phase out the platform it will go to a no collision state, and then when we return, that's not where that one goes, like so, then we want to return it to collision enabled. And that should be all. Now we just need to have some way to trigger these, and what we can do is we can have a we could have a timer or a timeline or something like that. So let's start with a timeline, and or let's do it simpler. Let's do a timer by event. So we say every, let's say, 5 seconds, just for test for now, and we can promote this to a variable also so we know the timing. And we'll call this the timer event interval, like so. And then we need to hook up an event to that. Call this the phase in and out. Spell it correctly, like so. And then we can set it to looping, so that when we start playing, or when this object is created in the world, it will start a timer. Whenever that timer has expired, it will trigger this event, and then it will keep doing that. So because we have looping, so every time the interval happens, it will call this. And this event in turn can call the phase out and phase in. So to be able to do that interchangeably, a node that could be useful for this would be the flip-flop. So it would do first the A, then the B, then the A, then the B, alternating between those every time this is called. So we can start with a, that's not what we want to do at all. Call them phase out platform event, and we call the phase in. That's not what I want to call either. Phase in platform. Is that not what I called it? I spelled it wrong. I thought I'd fixed that. There we go. Phase in platform. Like so. So now we have essentially built the platform that will phase in and out. However, for now, all that it will do is it will change its collision. It won't actually disappear. If we were to bring it out into the world and maybe change the timer on it to be something shorter so we can see it more quickly, something like 1 second, and we play, we can see that the platform is going to be here all the time. But we can also run through it every now and then, because it will be phasing in and out. To better represent this, we could also make it so that the platform is actually not visible when it phases out. So we do this by setting the visibility. Like so. So when we're phasing out, we want the new visibility to be false. And when we're phasing in, we want the new visibility to be true. So this should now be represented well by plopping in and out of existence, and it's also colliding with us when we expect it to be colliding and not. So that's our basic functionality like so. We can also do it so that the interval over here is something that's instance editable, which allows us to have multiple platforms that all have different intervals. So this one could be every 2 seconds, and this one could be every 3 seconds, and this one could be every 4 seconds. I changed the wrong parameter here. Like so. So now you see they will be fading in at different times, though the color makes it a little bit difficult to see. But yeah. Okay, so that's the basic functionality for that. Now let's create some very simple obstacle course with the help of this. Maybe we want to also have, let's see, if we put this to 0, I'm not entirely sure how this will react. Does that mean it will stay forever? It does. That's good. That means we can actually use that for also having some platforms, because we want to make it like a challenge for the player to maneuver the course, but we also don't want to make it like super stressful and too difficult. So if we were to put some of these platforms so that the player can jump on them, we also might want to have some certain areas that work as sort of like a checkpoint or something like that, so that when a player has reached a part of the course, although now 1 second might be a little bit evil, let's say 4 seconds, and let's say 8 seconds. It was phasing in and out a little bit quickly there. So that when a player actually managed to pass a part of the course, which I of course failed at doing, and no. Then the player can at least have a moment where it takes a breath and reassesses the situation. Okay, this will be a bit of tweaking. We'll do that later on. So for now, what we want to do is we want to create an endpoint where we say the game is over. So let's create a class for that. BP game over. So this object, again, we make a static mesh for visual representation. And we make a cube. And we create a do we even need to? Let's have the whole cube act as the our volume to determine if the player has reached it. So we'll just do a no collision, actually a custom. We will allow the pawn to overlap and everything else to be blocked. That should be okay. Collision enabled query in physics, collision query no physics. Let's go for that. And then we'll create some event for this, for begin overlaps. When a player enters this, we will stop the timer that has been running throughout all of these levels, and we will present a result screen for the player. So to do that, we need to first have a screen for the player to actually display. So we'll create a widget under user interface widget blueprint. We call this w underscore game over screen. We'll go into that and we will say let's put in some text. We'll anchor it to the top of the middle, so that's its reference point. We'll reset the position of x and y. We will put alignment to 0.5 along the x-axis. Now that we have its position, we can actually toy with the position y a little bit. Maybe have it 200, something like that, and have it say game over. And then we can have it a little bit larger of a text so that we're really sure that we have really ended the game. Where's the font? There's the font. So let's say 48 maybe. And we'll click the box size to content. In addition to this, we want to show the player what its score was, or its time. So we'll make a text for saying your time was colon, and let's say 12 seconds, 34 partials of a second. We'll anchor it to the top of the middle as well. Reset x, alignment 0.5 in the x. Let the position be, well, actually this looks like it's an okay position. And we'll make this a variable and we'll rename it to time text. Like so. We'll maybe make it a little bit larger, also 36 or something like that. Then we'll go in here and we'll do a event. And we'll do this. We will set the time. This is our variable for the time that we had. I am thinking we could have it as a parameter in. So let's see here. If we go to the... Now I need to close down a lot of my blueprints here because I'm having too much and it's becoming difficult to maneuver. So we have the third person character. And at some point it's gonna get a game over event. So let's create a custom event, call it the game over. And when this happens, it's supposed to create a widget of the type game over screen, like so. And owning player is get player controller. And then we add it to the viewport. However, we want to send in our time here as a parameter. Now, this should be possible if we expose this variable, but I don't see the property that I'm expecting to see. Let's try something else here. Let's do a separate variable. Game over time. Yeah, it seems I need an intermediary. So we'll make this a float. And we'll call this instance adaptable. Actually, that doesn't matter. Actually, it needs to be. Anyway, what we need is the expose on spawn. That allows us to have it as an in parameter to the widget itself, which means if we go back to the third person character and we right click on it, this create widget, and click on refresh nodes, our input parameter here now, the game over time, will be available here, which means that we can use that on our construct here on the widget, because that means if the character sends in the time in here when it creates the widget, then the widget knows that this variable has been set, so we actually have this information available when we call the construct here, meaning we can take our time text, set text, there, and then we can make a format text, so we can make something nifty. We'll say, let's see, what did we have here as the default here? Your time was. We'll copy that, take that in here, and erase the time in here, and instead put these squiggly parentheses and say game over time, and then end squiggly. Then we get a variable that's exposed, which we can use for our game over time. So that should work. Let's try this out by making a simple event for the key E, which will do the same thing here. So we'll just try it out and see if it appears on the screen like we're expecting. So this is what it will be looking like, and that looks okay. So we can remove that. Now the game over time itself is going to be something that we keep track of all across the whole game. So it's something that we need to be pushing through from each map, or we need to keep track of it in the game instance. Now we could have it like load into the game instance and then load it out of the game instance into a game mode or something like that and have the game mode keep track of it. Or we could just access it from the game mode. Either way is actually fine. It's a matter of how you want to, or whatever you feel is the most logical way of having your information. But let's say we put it in the game instance. So we need to get the game instance. Now we haven't created a game instance yet, so if we go to our edit project settings and go to maps and modes, you'll see we have a game instance here. This is the default one that gets created. We'll press the plus sign and we place this in our blueprints, and we'll call this BP game instance. With that created, it automatically opens, and we add a variable here for game time, like so. We need to change the type to be a float, like so. And we also need to have this game instance in the third person character casted to this new BP game instance, so we can actually access the time from it. And let's give ourselves a little bit more space. Get time and hook that in there. So now we have the functionality of the game over being called, or doing this when it gets called, but we don't call it from anywhere right now. And that was meant to be done in our BP game over. So we'll go over here and ask the character. We should not have a character, we should have a third person character, because that's where we put our method, which is called game over. I am considering if we should do this better, because generally speaking you don't want to have logic like game over logic to be handled in random classes like this and then in the player class, the pawn class. You would want to have it somewhere where it makes more sense, like the game mode. I think we'll be fine with this, although that's something for you if you want to build upon this further. We'll see. I'll consider it a little bit and see where we end up, but for now we'll put it here. So when this is overlapped, the game over is going to be called. Let's try that and see if that works out. It should be this little box. So game over. So that will be our end. Now we need to keep track of the time between levels. So we need to make sure that we keep sending this information over to the levels. And the way we have the transition between levels earlier is that we have our blueprint for teleporting. So if we find our teleporter, when we enter here, this is where we leave the level and go into a new level. So before doing the opening of the new level, we want to get a game instance here as well. We want to cast it to our specific game instance, which holds the information about the time. And we want to... Actually, we don't need to do that. Because we put it in the game instance, then the game instance lives the whole way through. We can just keep... we don't have to transfer it between, like so. It'll just be there. What we do want to do though is get time. So this is the time in seconds since the world was brought up for play, which means this will be lost every time we create a new world. So we need to add it to our game instance. So we get the game instance, cast it to BP game instance, and this is so that we can get its time, and then we add it to whatever time we currently have before then putting it back into the game instance. Like so. So that should handle the transitioning between levels, making sure that we keep track of the total time on each level. Which also means that we currently do not have it right here. When we do the game over here, it's getting the game over time, which is getting from here where we're getting the game time, but we're not actually adding the last portion of the game time that has occurred since this last map was created and this. So let's actually create a game mode to keep our information in. I think it'll become more structured, so we'll have to change a few things. Yes, so let's go to our project settings. Then you have third person game mode. Actually, I'm not yeah. So BP third person game mode. Then we'll doesn't want to browse it. Let's find it manually. So what we want to have is this game mode actually do all of the stuff. So let's create a game time here. Like so. And let's say we create some functions here. Let's say we add a let's create a function called add game time. And it takes an input that is float and it returns an output that is float as well. So game time to add total game time. And this is simply so that we can call this instead when we want to teleport, for example. We'll just say to the game mode, this is the time I want to add, and the game mode itself handles everything. And in the case where we have the game over screen, we want to know what the total is, so that's why we're adding this to the return node, so whoever wants to know the total can also do that. So we'll take the game mode's game time, we will get game instance, we will cast the game instance, cast BP game instance, like so. We will get time, we will set time, and then we'll clean this up a little bit. So the game time that we set it to in the end is the one we're going to be returning. We want to be adding the input game time, so. And the result is that. Trying desperately to clean this up a little bit so it becomes more visible and readable. Something like that maybe. Actually, the game time sort of becomes superfluous, so we can remove that. It will still be stored in the game instance, but the game mode is the one that's handling all of the interactions with the game instance instead, like adding the time. Now let's go to our now we run into a little bit of a difficulty here. Because this is a third-person game mode, and the third-person game mode is something we only have in certain maps because we have done some different game modes for each map to make sure how you can use game modes. Now we run into the problem of actually first of all, we have to, if we were in the teleporter, we would have to cast to a specific game mode to get it to we would have to cast the third person game mode to update the time of it. But we also have a first person game mode and we don't want to do multiple casts. That means we should make an interface instead. So let's do that. We will start cleaning. It'll be a little messy for a little bit here, but bear with me and we'll fix this. So we'll create a blueprint interface. Call this handle game time. And we will actually remove this function that we created. We want to, let's try and cut this by Control X and then Control V to paste it back in here just so we have the code. So we don't have to redo that. So we remove the function called add game time here. We go back to our blueprint. Where is it? Why can't I see it? Maybe we didn't open it. Handle game time. Let's say that we have a add game time. Now this is an interface that we will be having on our game modes instead. So we will go to our class settings for our game mode and say we want the BPI handle game time. Now it'll get the interface of add game time here. What we want to do is we want to make sure that this represents what we had before, which is that it has one input and one output, both of them being floats. And this is the game time to add. This is the total game time. So now we have defined what the interface is going to look like. If we go back here and we say implement this event, then we'll get a function that has basically the same look and feel that the last one did. Now we can copy this code out again and put it back in here and hook it up. So now the benefit is here that we have created an interface, so we know that this will be handled in all the game modes that actually can handle it. So if we go back to our teleporter now, we remove our game instance, we remove the cast of the game instance, and instead we do a get game mode. And what we do here is we say add game time. Now this is going to be called on all the game modes that has this interface implemented, which is good for us, since then we don't need to know what kind of a game mode it is. And let's see here, we want this one to be hooked up there. that game time is the actual time we want to add. Remove this, remove that, like so. So to reiterate what we've done now, we have changed it so that when the teleporter gets entered, we make sure that it's a character. If it is a character, we get whatever game mode we have currently, we don't need to know which it is, and we tell it to add game time. If it has this interface implemented, then it will be adding the game time that has expired since the creation of this map. And if we wanted to, we could get the total out from this as well here, but we don't want that when we're doing the teleporter, we just want it for the game over. And then after that we just open the next level and we continue from there. Now we do need to do this thing again in our in the handling of the game over. Before that we probably want to do this also. We have our other game mode. Let's see if we can find it in an easy manner here. Can we cannot sort by game modes. Let's see if we can find if we have there BP game mode level 2. So this one needs to implement the interfaces well for the handling of the game time. Not open graph, like so. And it needs to do the same thing as the other one did, so we can copy this code actually. Because it should be using the information in a similar way. Lost the cast, so we'll cast it again, like so. Okay, and let's see here, we have the BP game instance needs to get its time over there. And we need to set the time on the game instance, we need to hook that up over there. So that means we should probably have our functionality now for transferring the time between levels. Now we probably want to see it feels a bit convoluted, because what we could be doing here is when the game is actually over here, this end area should probably call the game mode and tell it the game mode is the game is over. The game mode itself should probably do some validations if there's like any to be checked to make sure that it is actually over, and then it would be calling the game over to the characters. But since this game is so very simple, it feels a little bit redundant and convoluted to do that. So I still think this is probably good enough. But we do need to change this though, because we're not using the game instance here anymore. We're using the game mode. And we want the cast... No, not the cast, we want the add game time message, because the last level hasn't been counted here yet, so we need to get time in seconds. And we hook that up there. And then we get our total out here, which is the total that we're going to be using for the widget. And that is hooked up. So a quick test for this would be to actually run the last level, because it will get the seconds of that level having existed at least, and then add it and then send it out, so we can see if that works. So here we are on the third level, we run in here, we get our time, which is 2837. Let's try a little bit more advanced one. Let's go to our level 2. We should probably restructure how we have our maps as well at some point. Now this level doesn't actually have all of its functionality here yet, so we can just do this where we move our glass barrier so we can play from here and we can just run in and teleport ourselves. But to make sure that we have a time that has actually taken a while, so let's wait here for a little bit, so maybe 10 seconds or something like that has elapsed, and then when we get teleported to the next level we run immediately into the game over. So if we know if the time is over 10 seconds, then we know it has calculated both of these times. If it's like only a second or something, it has only calculated the last, and then we'll know if the transferring of the time between these would work. You can do better tests than this, but this is just a dirty test. So we see the time is over 35 seconds, so that seems to be working. So now we're getting the times transferred properly. That's good. So now we have basically concluded everything that we need to do on level 1, everything that we need to do on level 2, and everything that we need to do on level 3. So let's take a moment and work on the main menu level then, the actual starting level that the player will begin in. And then once we're done with that, we can actually go back to all of these levels and make these different systems, blueprints, objects, and levels into something that actually is hopefully a little bit fun to play with all our systems in place. And after that we'll make a pass of adding some fancy assets from the marketplace to make it look a little bit prettier. And then once we've done that, we will make another pass and see if we need to polish some things up. But let's go to the main menu level. Now, main menu level, let's make a blueprint folder for that as well. So we'll call this the main menu. This level is just going to be a very simple HUD that appears where it tells the player to choose one of two different classes, and depending on which button the player chooses, it will load into the game and it will have a different avatar depending on which of these buttons it pressed. We will make it fairly simple, but just to bring the point across of how it's done and how it can be used. So the first thing that we're going to be needing is a actual widget blueprint. So we'll start with that. So we'll make it, call it w underscore main menu. And then we'll open that up and we'll make something super simple. We'll make, let's say we do 2 buttons. And then we'll make a text. So the text we will anchor in the top middle, the buttons we will anchor in the top middle, or we'll anchor them in the middle actually, I think makes more sense. Like so, and the text will say choose your class. And we check the size to content box so that it fits in all the text inside of the element. We will reset the X position and we'll set the alignment to 0.5 so it's always exactly in the middle. Let's lower it down a little bit, maybe 300 pixels, so we feel that it's somehow connected to the buttons. Make the text a little bit larger. And I think that's fine for our purposes. We don't need to put a lot of effort into the UI. It's not going to be one of our main focuses. We're after the functionality primarily for now. When it comes to the left button, we'll reset the X and the Y, and we'll set it to 0.5 in the Y, and the alignment doesn't matter that much. Let's set it to 0.5 just to be normalizing. Anyway, so we'll want this a little bit to the left, so we have some space to the other button. So we'll have an X position of -100 maybe. And we can put a text inside of that button that says, let's say warrior. So this is supposed to be our warrior button class. We can choose the button and pick size to content, so the button will adjust according to the information inside of the button, which is the warrior text right now. We can also choose to have a different color for the texts to black, so maybe it's a little bit more apparent. And then we do something similar for the other button. So we have it centered in the middle already. We reset its position. We'll set its alignment to 0.5 in both axes. And the left one we moved minus 100. So let's move this one plus 100, so it's symmetrical. And we'll add a text to that button as well. And this text will say mage. So these are the two fictitious classes that we're gonna have. Of course, we don't have mages or warriors, but just to drive the point across. Like so. And then we want to... Here we run into a little bit of an issue, you might see. We were after symmetry, but we have sort of lost symmetry now, because our buttons are... I said I wish we shouldn't be putting too much effort into user interface, but just to explain this a little bit, we have put both of these buttons to be fit size to content, the checkbox over here. And because the word warrior takes up more space both in X and Y directions, the button is bigger in that regard. So maybe we want to actually have these buttons a fixed size. Let's say 150 times 60, and not size to content instead. And then we do the same for this one. So 150 in X, 60 in Y, like so. So now they're more symmetrical. Anyway, so now we want to click on one of the buttons and just click on the on-clicked event down here. That'll bring us in here, and then we can click on the other button and we'll get an on-clicked event for that one as well. Just to be a little bit proper about things, we can choose to rename this into the warrior button and have it's gonna be variable, because buttons are always variable by default. And we have the mage button. This way, when we have these names descriptive like this, that allows us to more easily see which button is which, instead of button 1 or 0 or something generic like that. Anyway, what we want to do now is we want to store the information that you get from clicking one of these buttons into our game instance. So we want to find our game instance. And we don't... There we have it. And then we want to say chosen class. Now we could store this as a variable like integer or something like that, or we can do something a little bit more with more effort, and we'll go and create another enumerator for this. So this will be our E classes. So we'll make two inputs here, one for warrior and one for mage, like so. Then we go back to our game instance. Where did you go? There you are. And we'll change this type to our E class enumerator, like so. And the default can be... Actually, what you see here is we have only given it two options, which means that we only have two options to choose from. But sometimes you might want to put another option into the enumerator just to know that you have actually picked something, or so you don't actually get a default value from somewhere else unintentionally. Sometimes you want to want the program to show its mistakes so you can find errors. So let's actually add a third one, which will just make a slash, and we'll move that one up to the top, like so. That means that if we are ever to create, let's go back to the game instance, if you're ever to create one of these enumerators, it will default to this one, which will call an invalid class, and that's way we will find out. Now we go back to our main menu, we get our game instance, and we cast it. We do this for both buttons. And then from that we want to actually set our class. Now that we have chosen an enumerator like this, that allows us to have these fancy drop-down boxes here, so we can just go warrior for this one and mage for this one, and it's all pretty. As the last step from this, we want to actually open our level. So open level and by name. And we can actually do this if we want to as well, since they're both going to be congregating into this point that they're here. So we'll add a variable for level to start on. We'll edit it to an enumerator of levels type that we created earlier. So that means we can drag this one in here, like so, default it to level 1, drag out the connector node, type to string, get the type friendly version, we connect it to the open level, and that should be that. So now the widget should have all the functionality that we're expecting of it. Let's go and make sure that we actually have this level throw this widget into our faces. So we'll go to, we are now inside of the main menu, the level main menu. I think, I thought we were, I'm not entirely sure now. There we see, main menu level. And in this level, technically we wouldn't need anything in here, we could have it completely empty. And we might actually do that. But for now, we're gonna do, you're gonna click on blueprints up here and then open level blueprint. And the level blueprint is a blueprint that only exists in that level, and it's generally not a blueprint that you want to have much communication with because it's a bit problematic. But for cases like this, when we want to have a main menu, it sort of makes sense, because immediately when you start this level, which is begin play, this is supposed to be only a menu. So on the begin play here, we can immediately go and say get player controller, and we can say create widget of the main menu version, and then we just hook these up, and then we add it to viewport. Like so. And also we want to make sure that we actually have a mouse, so we'll drag out from our controller and type in show mouse, set show mouse cursor, put that to true, hook that up, redirect our node a little bit. So when we start this level now, we're gonna get our menu thrown in our faces, and we have our mouse cursor available, and we can get to choose one of these classes. And if we choose a class, we'll get teleported into the first level. Now, the first level there you saw just put us in our normal character, but what we want to do is we want to go to our where do we have it? We have it in blueprints, yes. Third person character here. So we'll create a child, which is called BP Warrior. And we'll create another one that's BP underscore H. So these will be our different classes that we will be able to spawn in with. So now we're gonna do something that I normally don't do when it comes to single player games, but yeah. If we go to our blueprints, let's check our level 1 actually. Do we have... we have the default game mode here. Okay. let's go to project settings and see which one is our default one. Our default game mode is BP third person. Okay. Now, this game mode is the one that handles the first level, but actually also the following levels. Let's do this. So in game mode there is an event that is available if you right click and you type in post login. Is that not what it's called? Login post. Ah, okay, sorry, I'm in the function, of course it's not gonna find it there. Post login. So there's an event called post login. Now post login is an event that is called every time a user connects to a game. So if you have a multiplayer game, like for example a lobby, and then new player joins that lobby, then the game mode would get a event on post login, and this input here is the controller that player has been assigned. So this is basically the player. And then in instances when you have like you move from a lobby to an actual map together, all of the players that were joined in the lobby, you would get one of these post login events on the new map on that game mode for each player that joins. So that is sort of what we're going to be doing here now. So on our third person game mode here, we're going to find out which of the classes that we chose in the beginning is the one that was saved, and we're gonna spawn a character based on that. So let's start off with getting our game instance, like so, and we cast it to the one that we have, like so, and then we say get class. That's not the one, right? Get chosen class. This is not ideal. Let me think about this. Never mind, we can make it work. Let's make a switch on this. So a switch on an enumerator will give you an option for each of the available options that the enumerator can have, which are these three that we defined earlier. And then we'll make a spawn actor by class, spawn actor from class, like so. So the slash hill will represent our fallback plan, but otherwise than that we want to spawn a class of warrior when we have the warrior node selected, and we want to have a mage there, BP mage, and when we don't have one of those we can just spawn a third person character or something like that, just so we have something. Now these are of course gonna visually look the same currently, but we can make sure that we have the right classes with a little bit of dirty testing later on. In addition to that, we want to do this. We want to split the structs of the transform. Now, the reason we do this is because it's quite often an issue when we're going to be doing this. We're going to get a actor by class, and this is something you generally don't want to do, but since this is just going to happen every time the player enters the map, it's fine. It's not that bad. And we're going to be wanting a player start. So the first thing we do is when someone logs in is we want to find what are the player start locations on this map, and we're actually just going to get one of them because it says actor, not actors. So the first one we get we're gonna get the location of. Location. Like so. And this is what we're gonna be using as our spawning location for the new classes that we spawn in. Like so. Now, these were originally transforms, and you could technically get a transform from the starting location. However, I would recommend against it because sometimes you can get values that are a little bit weird when it comes to like the scales, which means your character will get sort of messed up when it loads in, and just to avoid that we're doing it like this. Because the spawn transform of 1 is what we want and the rotations we don't care about. Now with that done, we're gonna make a reroute node for our controller because we're gonna need our controller now. Because all of these different pawns that we possibly have spawned now, we're gonna take possession of that one with the new player that entered. So we're gonna type in possess, and we're gonna copy and paste that for each of these. The pawn goes into the pawn connection. And in the target we have the controller, which we have rerouted now here. So we'll drag that one up here. We'll drag this one up here. So when a player loads into the map where the third person game mode is active, we'll get a start. We will get the game instance to see which was the class that was picked, and then we'll spawn a character of that class, and then we'll take possession of that class. So I think we're ready to do some testing, I believe. So main menu and warrior, and we end up here, and this is not what we expect to begin with because that up there is where we want to be, right? And the reason for that is if we go to level 1, we have a player start down here. Now this player start we want to drag up and have up here where we expect to be starting, above the glass ceiling, so to speak. So something like that, and we'll remove this character over here. So let's try that again. Main menu level, pick a character, picking the mage now, and we get spawned up here, and we can do all our stuff like before. And we get possession over this one, we teleport over here, we can start blasting stuff. Everything seems okay so far. Now we need to make sure that we're actually spawning in as our proper character. Actually, yeah, we should probably. So let's go to our blueprints, in our mage, and in our mage begin play, we'll just type in a message, print string, say I am a mage. And then for the other one, we'll say I am a warrior. That way, whenever we spawn in with one of these characters, we know if we have spawned in properly as one of the warriors, the mages, or if we get the default one, we can say nothing at all, and then we know something's wrong. So, spawn, warrior, it says I'm a warrior up top left. And let's just try it out with the mage as well. And it says I'm a mage. So the spawning of the classes is working fine. So now we actually have more or less the whole playthrough logic. We can go from the start menu to the first level. We can do things there. Theoretically, we haven't really set it up much yet. And we can get to the second level, we can get to the third level, and on the third level we'll get a game over screen. So let's actually start sprucing up our levels and make them into something a little bit more interesting than just like these disconnected blueprints that we have created so far. This is the end of part 3. I hope to see you in part 4. Keep on learning.